This is Deepak. Today I'm going to cover a very important question related to plain map reduce called distributed cache. This can be asked in interview also how to use distributed cache in map reduce program. Many companies who use Java, still plain old map reduce Java programs they want to maintain. So in that case they may ask these kind of questions: how to use distributed cache, what is distributed cache. Now distributed cache is basically a framework where you can pass across the job files. If you have a number of files, common files which are needed for each of the map job. Say you have a file which contain all the countries lookup code which you want to join those data in the map operation, uh, join the countries and some address details. So if you have such a requirement, then you would like to pass across the uh, same file on all the map jobs where you want to where you have the split address details, but the each map split needs to join with all the data of all the countries in the same place. So that thing can be done, this process can be achieved using a distributed cache. And basically to do it you need to have your distributed cache located in an HDFS location. It should be present in a HDFS path. It should have the URL as HDFS, and it will, based on the map produce, we'll look at the permissions that you set for that file, whether it is public or it is private. Private means it will be available only for people in your own HDFS user and HDFS user group. Public means it is available for all the, it is read only to everyone in this, uh, everyone around. So it will be permission like 754 or 755. So for the distributed files, so in that case everyone can access it, so that becomes your uh, public distribution. So you can look at this screenshot to understand how you will define the public versus private distributed files. So that's it, and you will be able to add a distributed file. There are some ways through which you can specify the distributed cache. One is mapred job cache, and make give the value for the files. So use this property to set a comma separated list of all the distributed files. Mapred job cache dot files, that is one way. Other ways you can use the job dot add cache file or files to give a list of the distributed files that you want to pass across to all the mappers. Now we'll look at a code where we'll run using distributed cache technique. So let us look here and see there is I have a code for this type of purpose. So in this code what we are doing is, uh, I hope you will have seen this concept of passing parameters, right? So additional parameters, enhanced parameter inputs in MapReduce, that you can check that video. But for using the distributed cache, what we are trying to do here is we are trying to count the words in the file, and we want to ignore some words from getting counted. So for achieving that, uh, what you are doing is we will use the generic option parser class for, and we'll set a data separator, some separator value for text output format, and that for separating the data, and when you are displaying the output. Okay, now the key thing is, one thing to understand is Instead of using regular argument reads, we are going to use the generic option parser class, which is very powerful, where you can separate the different config options that you pass, and you can separate the various other parameters very easily using this generic option parser class, where parameters are the conf and argument, and you get the remaining arguments, the argument non-config options using the get remaining args out of the option parser, and we are just printing them. And now you're gonna see that just ignore this, like we are trying to ensure that we pass either three. Okay, hold on, I'm folding the wrong one. Okay, this is the code. Okay, so here also it's the same thing. Uh, we will be taking the input and output, and in case we want to skip, you have a distributed file called which contains all the patterns of words which we don't want to read, like and the some common words we don't want to use in word count, that we'll put in the patterns file. Okay, and so we'll set up different parameters like the mapper, like you would have seen it in my earlier videos on basic concepts of setting up the mapper jobs, uh, map reduce jobs. So you set the jar, the class, the jar name, which is the current word count, map reduce, input output value, all that class, reduce combiner class. uh, then here you are getting, here if you get a parameter like skip, then you are getting the passing the setting the parameter word count skip pattern as true, and then you are adding the catch file using the add catch file to add the given distributed catch path. uh, so it is this next argument will be the remaining the distributed catch, converting into a to URI. So the given parameters converted to a URI format and added to the add catch file, right? So you use the path class to convert a given string into a path, and from that you are converting it to a URI and adding it to the add catch file. Then you are adding the input path using a new job for the given job. You add, you put a new path, use the path class, and you will get the first argument, which is the given first argument is the input and file output, and set we get the path as the uh, other args dot get one, which is the this thing is the output location. And this is, you understand that. Now in order to use the um, use the distributed catch, we have to first load the file, distributed file, in our map program. For that, what you do is, in our mapper, this is our tokenizer mapper class. Inside this we are going to define the setup, we are going to override the setup object. Okay, so setup object is used to pull the distributed catch file inside the map program. First you get the configuration, and then from conf you are gonna check what is the value of the word count case sensitive. If in case you want to do a case sensitive word count check, you will set this parameter as true, and I'm just printing it here. Then if skip patterns is set as true, that I'm going to skip patterns, I'm gonna then uh, I'm gonna get this patterns URI is, I'm gonna get list of catch files using the job. For this job I get a instance of this configuration, and for that configuration I'm gonna get the catch files, all the files, and I'm gonna check in all the patterns of this catch file. And I'm gonna, once I get that, for each of these path, I'm going to get a pattern create a patterns path from this given path. So you create a new path using this URI get path, which is URI is a type of an um, URI is type of parameter which is stored in the catch files or the distributed files. So you'll get a pattern URI, the uniform resource indicator, and out of that you are going to get the path and the file name. So you are getting the file name. Patterns file name is the pattern path, and from there you get the name and you get the string. Get the file name using the get name function of the pattern path. Pattern path in is being the uh, catch file path. Okay, so for so bottom line is each catch file will come here. Each catch file will location will come in the patterns path, which is stored using the new path, and which is called using the get patterns. For each pattern which is obtained out of the catch file, you get the path, and out of that pattern you get the name. Convert that thing into, well, make it into a string, and then you will get, you're gonna uh, read that file, parse it, parse that pattern. Now what this parse skip file is gonna do is it's going to, now this is a, we are going to read that. Okay, this FIS is a uh, so this is FIS is a buffered reader. Typically in Java you will use buffered reader and read file read together to read the contents of a file. So this FI is a private variable which is going to pull the contents of this file. So it's a new buffered reader which read the file buff build reader based on the file name which you have got out here. This file name is passed here, and this, I'm just printing out the patterns here. So you're gonna what you're going to do is this input of this file content, you are going to patterns, you are going to load it into an uh, list. So if you see patterns to skip is a variable which is an set, which is a set of hash set of strings, unique value set of strings. So so we are going to pull the stuff into this hash set. Each line will be a pattern to be removed from the text, so we are going to add this into the patterns to skip. So finally what you understand is like pattern to skip contain the list of all the different patterns to be skipped out, and any exception you're gonna write this IO exception because you have handled already the IO exception in this setup uh, method. Now you're gonna what no sorry that now what you're going to do is once this setup happens, you're gonna get the value of all the patterns in this set. Once it, once the pattern goes, all the patterns go into this patterns to skip, then the map job will start using it. Now here is a map job. Now this is how we are going to use the distributed catch inside. So the from distributed catch you pulled all the patterns to be removed into this pattern to skip, right? And here I'm going to use convert all things. If I'm going to use case insensitive, then that means I don't care about the case of the word, and if it is case sensitive, it's false, then I'll convert to lowercase, otherwise it will keep it the way it is. Then I'm just printing here the patterns, and then we will check for each of the pattern for this, since this map operation takes place for each every line, right, of text. So for each line we are replacing, for all the patterns that are given loaded in the hash set, we are replacing the pattern with nothing. So finally we will have a, we'll remove all the bad words which we don't want, and then we will use the string tokenizer to tokenize this, convert split it by space, and load, and for each of that token we are going to write in the context dot write the word and one, which is basically an int writable with the parameter as value as 1, and the word will be this current word. Okay, so let us now look at uh, the code. Let us execute this code. Let's go to Cloudera. So you have I have already have the code here. So if you see, there is an patterns files here. I don't want these words to be considered, okay? And I have I have already moved the data. We will run the code now. Let us see this running. Okay guys, anyway, all the code will all be there in my GitHub account, which I'll be giving. You guys can use it. I'll later upload it as well. um, let us have a look here. Where is this? Yes, patterns. Yes. So this, I'm gonna run this. We'll put the case sensitive as true, and we have already loaded this file in this location in HDFS. Okay, so if you see, if you look here, you have this data in HDFS. Okay, and let us look at what is there here. You'll have two files here. Let us look at this. So you have first this and this data. Okay, look at this, and you have the second set. Right, now what we can do is we'll run this code. We'll load in another output. So this is going to be case sensitive output. In order to print the output, whatever I want to print, you have to set this option log4 our Apache Hadoop equal to debug. Then all our system out println will be printed. So the logger class, under that you have the OR and you have Apache and Hadoop. You enable debug, and this case sensitive variable I'm setting it as 2. We can even set the number of reduced tasks as 1 here. That is, we don't need to. Let us do it like this, and let us run this guy. So you can see that there are 3 input parameters which are printed, 4 parameters. Now this is the can even monitor this map reduce job from here, this application. Come on, it's a little slow. Don't know why I don't know why you're doing this like to me today. Okay, so it is not yet started. It's just in accepted status. Then it will go into the running state. Actually, job has not yet started. Now it is in running status. You can click on application master and click on this. Actually, my laptop has become slow because of I'm recording videos also at the same time. Maybe that's what is causing the performance degradation here. Uh, anyway, that's okay. We can wait. The map jobs are in running status. They're still running right now. Okay, maps are completed. You can see the map job is completed. Let us have a look at the map job. Let's see if the logs are created here. Right out the logs are generated. Okay. Well. Actually, it should generate more logs. Let us look at out log URL not configured. Okay. All right. I think there's some problem here. It's we can check the logs later using the maybe the later we will be able to check these logs. Let us leave it for now. Let us look at this. Let us look at the output data that is generated here. So since this was the um, right, this was the glob. This is the thing passed. Let us check the output directory. So it has generated one file. Let us have a look at what the heck is the data in there. What is there in? And you should be okay. Oh, interesting. So we set the case sensitive as true, so that's why it created a case sensitive, and so it didn't ignore the Hadoop and all. uh, Let us quickly have a look at this patterns file. 1 second. So it is Deepak. Okay, so it should remove Deepak and should also remove the. So let us run the same thing with the case sensitive as false parameter, and let us make it to another output, otherwise it will throw an error. So it should remove the should be out, and it should remove the should be out, Deepak should be out in this new output. Let us verify that. Oh, this is a very huge recording. I don't like big recordings. Okay, hopefully it should get completed in a minute. Yeah, I'll just pause it, and when the job completes, I will show you the output. Okay, the job is completed now. So let us look at the output now. Um, let's look at what is the output. We don't expect Deepak there. The is not there. Yes, so we got as we expected. Deepak is out. The is expect out. So wonderful. The distributed catch worked. The case sensitive logic worked. All those things worked. So I hope you learned a lot from this video. Thanks for watching, and I'll keep on creating a lot of videos on Hadoop. Anyway, this video got long, too long anyway.